Okay, good morning. What we're going to do today is we're going to look at the LabVolt central office test set. And the first thing I'm going to do here is I'm going to explode this view up here a little bit so we can see what's involved here. Alright, so now we're looking at the inner workings of the interface, and we'll look at the interface for the first phone. So the first thing I'm going to do is I'm going to take phone number A off hook, and notice that when you take the phone off hook, what you see is you see the line current here. So normally the central office, which is this block here, puts 48 volts on the telephone, and when you actually pull the receiver off, you put the network of the telephone on the line and you're drawing 36 milliamps of current. We can also use an oscilloscope to measure the voltage on the line. Let's do that, and we'll put a probe here on the line, and we'll put the probe right there. Let me just hang the phone back up here, and we're going to be looking for 48 volts. So we'll put this on continuous refresh, put the scope on DC here, and there we can see that we've got approximately, let's see, pull this whole thing down there. Yeah, you got about 48 volts. It shows 44, but it's a little bit more than that. 48 volts on the line there. Now let's see what happens when we ring a telephone. So now I'm going to take the other telephone. I'm going to ring the first one. So what the telephone does when it rings the other telephone is it puts 90 volts on the minus 48 volts there. So let's look at that. So there we go. So what we're seeing is we're seeing plus or minus 90 volts sitting on the minus 48 volts there. So one phone is ringing another phone, and the central office is applying that voltage on the line. Now, what happens when you answer the call is that the ringing stops. And the thing that stops it is the fact that you're actually drawing current here. When you lift the phone off hook, you start to draw current. It tells the central office that this phone is picked up and the ringing voltage stops. So the next thing we're going to look at here is we're going to look at the signal coming from the telephone. So let's put the probe there, and I'm going to go to AC coupling, slightly lower voltage, slightly lower time. I'm going to speak into the telephone. Okay, I'm speaking into the phone now. And what we should be able to see is my voltage there. So we're picking up the analog signal of my voltage there on the scope. That's the sound of my voice there. Alright, now as we move further down the telephone, in the central switch here, what happens is voice from the telephone goes into the subscriber line interface card, the SLIC, and then it gets converted into a pulse code modulation signal. So let's move this probe here. I'm going to move it over to this point. And what we're going to see at this point now is we're going to see the pulse code modulated equivalent of that analog voltage. So let me just increase this a little bit. Alright, so these are what we're seeing here are PCM pulses corresponding to the PCM equivalent of my voice. And of course, as my voice changes, these pulses change their values. And you've got different combinations of ones and zeros corresponding to different PCM codes that are created by the switch. So that essentially is a quick overview of the operation of the central office switch. It's exactly similar to what you find in a Bell telephone office, and your phone at home connects to a device like this. Thank you.